All right, hey everybody. So this is Miss Drake again, and it's Wednesday, and we are going to be doing Simplifying Radicals Day 3. I'm going to treat this like a review day. So instead of splitting it up into odds and evens like we've done the last 2 days, I'm going to go ahead and let's just work this whole sheet together. So you can try it on your own and then come back and check the key or check my notes, or we can work it together if you're still confused, however you want to do that. But we're going to just work straight through this worksheet to get ready for the quiz that you're going to take on Schoology on Simplifying Radicals tomorrow. All right, so you might want to have your chart handy if you haven't, if you are still using that, the one at the top here. So I'm going to have that handy, and we'll get started. So 90. Square root of 90, that is not a perfect square. Remember, you can test that in your calculator, or you can look on the sheet that we created. It's not a perfect square, so we've got to find the largest perfect square factor inside 90. So we're going to do 9 times the square root of 10. All right, so square root of 9 is 3, square root of 10. Hopefully by now you're getting used to emailing us questions if you have them. So I'm just going to keep moving. So we know 96 is not a perfect square, but the largest perfect square is 16 inside 96. So I know I have my 2 down in front. So I'm going to take this, got my 2, take the square root of 16 as 4, and then I have the square root of 6. So I have 8 square root of 6. 6 is not a perfect square, and it does not have a perfect square factor inside it. So we are finished. It is simplified. Square root of 75, that's going to be the square root of 25 times the square root of 3. Hopefully you'll start recognizing the largest perfect square within a number. So now I'm going to take the square root of 25, multiply it by the square root of 3. That is simplified. So we are going to move forward. We've got square root of 60. The largest perfect square inside of 60 is 4, and it's going to be 4 times 15. So square root of 4 times square root of 15, and I've got my 5 in front. Take the square root of 4, so 5 times 2, square root of 15, so you should have 10 square root of 15. By now, most of you probably have a shorter method of doing this, just because I know you guys, just however works best for you is fine. You can do it exactly the way we do, or you can come up with your own method. Just make sure you're not missing any steps. All right, 20 is not a perfect square, so I split that into square root of 4 times square root of 5. I'm going to take the square root of 4 and get 2, multiply it by the square root of 5. And then I'm also going to bring down my 6 in front. So 6 times 2 is 12, square root of 5. Number 6. You've got 108. You might need your calculator to help you test some perfect square factors. Once you do that, you'll see that 36 is a perfect square that goes into 108. Practice that. Don't just wait for me to tell you the perfect square. Use your calculator and help make sure you know how to figure that part out. You can use this chart that we gave you at the beginning. And what I would do is I knew I was looking at 108. So I would start below 100 and start dividing by these numbers from top to bottom, because you're looking for the biggest number. And when you got to 36, if you divided 108 by 36, you would see that 36 times 3 gives you 108. So again, that's the method. All right, so we've got 3 times the square root of 125. So I'm going to break that down. I've got my 3 in front. I know that that is the square root of 25 times the square root of 5. So when I break that down again, I'm going to simplify that. Square root of 25 is 5. Square root of 5 is as simplified as it can go. So that's your answer. All right. Here we go. We've got 18. That is not a perfect square, but I can simplify that into the square root of 9 times the square root of 2. All right, so if we're dealing with our numbers first, we know that we're going to take the square root of 9 and get 3, and then I'm going to leave the 2 under the radical. Then you can deal with your variables and the power over root. Remember, you do 3 divided by that understood 2 that's right here. And then you're going to do n to the 15 divided by 2. Just a few things to remember. When you're dividing, if it's an odd number power, you know that you're going to be leaving a p inside here. So 2 goes into 3 one time, so I take out 1 p, but it has a remainder, so I'm going to leave 1 on the inside. 2 goes into 15 7 times, so n to the 7, and then I'm going to leave 1 on the inside. 3pn to the 7th square root of 2pn is your final answer. All right, 45, here we go. Another one with combined. So I know this is going to be the square root of 9 times the square root of 5. So that's going to be take the 3 out, leave the square root of 5 in. If I write out my variables, I have x to the 7 over 2 and y to the 13 over 2. 2 goes into 7 3 times, so I'm going to take 3 x's out and leave that remaining 1 on the inside. 2 goes into 13 6 times, and then I'm going to leave that remaining y on the inside. And that's your final answer. You can just glance at what's under the radical and make sure there are no more perfect squares there. All right, we just have variables this time on number 10. So I'm going to do, I know I have a to the 1/2, b to the 2 over 2, and c to the 8 over 2. And y'all know what that means on this 1 over 2. 2 cannot go into 1, so I cannot take that a out. All right, so if you ever just have 1 of something under there, you know nothing comes out. You just leave that a under there. 2 divided by 2 means 2 goes into 2 one time, so I take out 1b, no remainders. 2 goes into 8 4 times, so I take out 4 c's, and there are no remainders. So that is my final answer. All right, number 11. I'm going to do x to the 8 divided by 2 and y to the 10 divided by 2. They're both even, so everything should come out from underneath the radical. That's going to be x to the 4th, y to the 5th. Number 12. We'll have odd and even, so we'll have an x left under there, but all the y's will come out. So you've got x to the 9 divided by 2 and y to the 14 divided by 2. 2 goes into 9 4 times, so x to the 4th, and leave that other x on the inside. 2 goes into 14 7 times, so I'm going to take out all of those, and there are no remainders. All right. Now we've added a number in front again, but it's all going to work the same. You can do things separately if you want to. Are there any perfect square factors of 14? So let's say I'm just practicing that, doing something in my calculator. 1 and 14, 2 and 7. None of those numbers, none of those factors are perfect squares. So that means 14 is just going to stay right where it is. So I have nothing to multiply by the 5, but I need to deal with my variables. So I'm going to have a to the 7 over 2 and b to the 18 over 2. All right. So I'm going to leave the square root of 14 on the inside of the radical because there is no way to simplify it. 2 goes into 7 3 times. So I'm going to take out 3 a's and I'm going to leave an a on the inside. 2 goes into 18 9 times. So I'm going to take out 9 b's, and I don't need to leave any underneath the radical. So sorry I squished that up, but that is the answer. All right, number 14, 64. I recognize that. That is a perfect square, so I don't even have to do anything. I know that that's going to be 8. And then I've got x to the 4 over 2, y to the 12 over 2. All right, so 2 goes into 4 2 times, so that means I would take all of that out, so I need nothing under the radical. And then, sorry for that, that's a 2. 2 goes into 12 6 times, so that's y to the 6th. And that's my final answer because everything worked out. I had a perfect square. 64 was a perfect square that gave me 8. 4 divided by 2 is x squared. 12 divided by 2 is y to the 6th. So everything worked out. All right, here's one where we got our parentheses. So I know Ms. Stoffergen talked to you about just copying and pasting once you do your power over root. with your understood 2, I want you to think about that parentheses as making that just one term. Just like we just dealt with that y to the 12th over here, and we said 12 divided by 2 gave me y to the 6th. We're doing the same thing. We're just doing 3x plus 2 is raised to the 2 over 2. So that's just 3x plus 2. 2 goes into 2 one time, no remainders. So that's my answer. You can leave the parentheses or take them off. I don't care. All right, square root of 16. Ding, ding, that is a perfect square. So we're going to just take the square root of 16. We know square root of 16 is equal to 4. So I'm going to multiply 4 times 4 right here. Then I would have x to the 3 over 2, y to the 3 over 2. 4 times 4 is 16. 2 goes into 3 one time, so I take one variable out for the x, or one x out, and I leave one x in. 2 goes into 3 one time, so I take out one y, leave the other y in. That is your final answer. 17, have a -1 in front and a 6. Remember, we looked at this on the notes on Monday. There is not a perfect square inside of 6. So we know 6 is just going to stay just like that. So I'm going to do -1, and I'm going to have times the square root of 6. I'm going to do x to the 20 over 2, y, look a little better, y to the 9 over 2, and z to the 5 over 2. So -1 times square root of 6, and then here we're going to deal with our variables. So we've got negative, and then I guess I'm just going to, sorry if I'm confusing, you can make your own pattern for how you do this. But 2 goes into 20 10 times. So that means I'm going to take out x to the 10th from here. I'm going to take out 4 y's and leave a y on the inside. And I'm going to take out 2 z's and leave a z on the inside. So it's up to you if you just want to deal with the numbers first and then deal with the variables, or however you want to do it. All right, here I'm going to have 5 times the square root of 225. And then that's going to be a to the 16 over 2. Guess what? 225, that's a perfect square. So I get to take out a 15. So I'm going to do 5 times 15. And then this is going to be 2 goes into 16 8 times. So that's just going to be 75a to the 8. It's the same process when you're putting it all together. And I know that I might say it a little bit differently than Miss Dr. Jen, but it's, maybe good for you to hear it a couple ways so you can pick the way that you like to think about it the best. All right, this is square root of 9 times the square root of 6. And then I'm going to have a to the 3 over 2, b to the 5 over 2, and c to the 2 over 2. So let's deal with this right here. I'm going to have a 3 on the outside, and my square root of 6 is going to stay on the inside. All right, so I've dealt with the numbers. Now I'm going to deal with my variables. 2 goes into 3 one time, so you take out one a, and you're going to leave the other a that's remaining on the inside. 2 goes into 5 2 times, so that means I take out 2 b's and leave a b on the inside. 2 goes into 2 one time, so take out a c. Remember that 1 is up to you. And you don't need to leave any c's in the inside because it's even. It divides evenly. All right, and the last one. So here we know that 9, we saved an easy one for last. So we know that 9 is a perfect square. So I have square root of 9. Then that's times y to the 5 over 2. Well, I know that the square root of 9 is 3. 2 goes into 5 2 times, and I have to leave of remaining y underneath. All right, so that is a great review for you to get ready for the quiz tomorrow. So work hard. Let us know if you have questions. Bye.